Go ahead.
Sorry, my name is Federico Cinus. I'm a PhD student at Sapienza University in Rome. And today with Marco, we are going to talk about the analysis and detection of echo chambers in social media. And so I'm going to start with a paper published at ICWSM 2022, where I'm going to explain our analysis on the echo chamber effect and how people recommender system interact with echo chamber effect. And then I will leave the stage to Marco that is going to talk about cascade-based echo chamber detection, which is a SAI-KM 2022 paper. So this work is a joint work with, again, Marco, Corrado, and Francesco from Rome, Turin, Random, Pisa, and Barcelona, different research groups. And the outline is the following. I'm going to start with some motivations. I'm going to talk about the models, a social network model, an opinion dynamics model, a people recommender system, and then our results. Motivations. So basically, there is a huge amount of information that usually when you consume them, this information is filtered by social media. This information is filtered by social networks. And so when we form our opinions, we usually do not see the whole amount of information, but just a filtered part of it. And when we form our opinions, then we take some action on the real world based on what we think about the real world. Some of these actions can be also extreme actions, as we can see in the phenomena that appear in real life in our societies. So actually, it is really important to study these effects and their causes. Especially right now, we cannot distinguish fake news. We cannot distinguish right now either if there are fake authorities that can then produce some fake news that spread inside the echo chambers, and then the action that we take can have a huge impact also in the stock market in this example. Okay, so the motivation are the following. What we expected with the rise of social media or social network was democratization, social connectivity, personalization, but actually what we see is a lot of misinformation, polarization, and echo chamber effect. So actually, it is kind of disappointing that what we expected is not what we found out right now. So you can ask yourself, what are the causes? The causes can be basically biases. They could be individual biases or group biases. So when we form our opinion, we are biased, or can be either algorithmic biases. So when we interact with recommender system online, and it could be also that they do mix. So the effect, the causes could be both at the same time. So as a researchers, what can we do? We can model, we can explore this effect, we can also detect them, and then we can just try to mitigate this extreme phenomena, working on, for example, the algorithmic part. So I'm going to start with three main blocks for our framework. I'm going to start with a network model. So we assume that each user in the social network is associated with a node in a graph, and each social relationship is expressed by a link in the graph that could be either direct or indirect. Here, we are going to assume that the link is direct because it's more general. And when we describe the network model, we can also see that in real life, there are some communities that could be far apart, and they can also be called modules of the network. On top of that, we can define a signal over the graph. So we define a controversial topic that could be Brexit, abortion, etc. And we associate with that an interval between of real numbers between 0 and 1, and each node in a graph can be associated with a real number that expresses its opinion about the topic. So we can have a signal over this graph, and we can model these in different ways. What we can find is that there could be homophily in the graph. So homogeneity inside the communities, which is explained here in the x-axis. So more homophily, more homogeneity is on the right, but we can have also a higher level of modularity, which means that there are less links, less edges between the communities, between the modules of the network, which is expressed here in the y-axis. Okay, this is kind of a static representation of the system, but we can think about it as a dynamic system. And so we can look at how these opinions evolve in time. And basically, we can find that this opinion can also aggregate and reflect the communities, the structural communities and modules that are in the network. And these are the kind of patterns that we want to study. These are the echo chambers that we want to find and we want to explore. Okay. In this study, we considered two different opinion dynamics models that describe how the opinions of each individual evolve in time. Here we are considering the bounded confidence model, which is kind of famous. So an interaction appears only if the opinions of the two individuals, their difference is inside a confident interval, which is called epsilon, and the opinion is updated with something that is proportional with a learning rate mu to the difference of the two opinions. So basically, from a high level point of view, there is a parameter epsilon that can drive the convergence to the equilibrium of the opinions. And this equilibrium can be a unique equilibrium, so one opinion, or a divergent opinion, depending on epsilon. We also consider another opinion dynamics model, which is called the epistemic model. So here you assume that there is one true state of the world. So one opinion is true and the other is not true. You can think about it in the vaccination debate. And basically the individuals take some experience from the real world. So they do some, they have some successes over some trials. They are basically acquiring experience in the real world. And then they update in a Bayesian style their opinion, looking at their experience and the experience of the neighborhood. Okay. The third block that we need in our framework is a paper recommender system. So basically, we can think about this in this study as a black box that is taking some information, structural information of the network, some other features that could be like the likes, retweets, etc. And is kind of producing a list of possible edges, so possible suggestions for each user, that are scored with a function, and this function that define a ranking of all the possible suggestions. To make an example, this is something that we see usually in the social network. So we open and we see in the front page, okay, you can add this person, you can add this other one, and these people are ranked based on a score-based function, which is given by the people recommender system. Here we used three main properties of the people recommender system. So we looked at local information with DJI, which stands for Directed Jacquard Index. So basically, we model the suggestions, the scores given by the people recommender system by looking at how many shared friends two users have. So if you have more friends in common, then I'm gonna give to that edge an higher score. Or you can also look at global information of the network by looking at personalized PageRank algorithms. Then we also introduced another algorithm, which is called opinion-based algorithm, which is kind of for us, it is modeling an extreme algorithmic biased recommender system, because basically we look at the difference between the two opinions and we give a higher score to edges where the opinion difference is small. So it is inversely proportional to the opinion difference between the two nodes. Okay, so with this framework, we can ask ourselves, can we assess the effect of this people recommender system with these properties, the effect on the dynamics of these opinions? So I'm going to present these results. As I was saying, we have these 3 blocks. But first of all, you can ask yourself, why doing simulation? So this is basically a simulation study. And why that? Basically, because you can avoid data unavailability using simulation. This is kind of cheap in terms of doing experiments. And the most important one is that you can do counterfactual experiments. So you can make use some parameters, you can make some intervention and look at the same simulation without the intervention. So you can measure and identify the singular effect. This is something that you cannot do with real data, basically. You cannot reverse the time, basically. Okay, so this is the kind of input of our framework. There is a graph with a signal, some opinions on top of that. We run the simulation with each opinion dynamics model, and we look at the equilibrium state of the opinions. And we do the same using each people recommender system during the evolution in time of the system. And then we compare the 2 final outputs. And how do we measure the difference between the 2 outputs? Basically, we reflect the same ideas from the people recommender system. So we look at local information. So we measure the correlation between the opinions and the opinions of the neighborhood of each users. And we look at also global information using the random walk controversy, which is an established measure of this global information. Basically, you measure what is the probability to go from one side of the opinion spectrum to the other and compare it with the probability to remain in the same opinion side. So again, this is the initial configuration, the counterfactual experiment, and the evolution, the state equilibrium with using recommender system on the right. What we found is that each recommender system, each people recommender system has a different effect. So on top, we see the initial configuration. On the right, without using the equilibrium, without using any recommender. And in the bottom of this slide, we see the different people recommender system. So the first one, which is kind of exploiting the local information of the network, is the one that is increasing the correlation between nodes and the first neighbors. So basically, it is increasing a local level of echo chamber in the network, while the second one, the one in the middle, PPR, which is exploiting a personalized page ranking algorithm, so which is exploiting global information in the network, it is increasing the RWC measure, which is a measure of echo chamber effect as a global scale in the network. Thirdly, the most extreme algorithm biased algorithm, OBA, is increasing everything. And moreover, it is also pushing the opinions of the nodes towards the extreme of the spectrum. If you see the colors, these are more brown and green. So it is pushing and creating much more 2 poles inside the distribution of opinions. So it is producing more polarization. The interesting fact is that producing echo chamber effect and producing polarization does depend on the initial configuration of the network. So basically, if you have a level of modularity, but more importantly, a high level of homophily, so homogeneity inside each community at the beginning of your experiments, basically you can get high level of an increment in echo chamber effect without using any extreme bias given by the algorithm, by the people recommender system. So each different people recommender system has its own footprint in creating the echo chamber effect. And of course, if you use OBA, which is biased by the opinion, you get a huge increase in the echo chamber effect. But what is interesting is the fact that for the other people recommender systems that are more realistic, you can get an increment in the echo chamber effect if some initial configuration and properties are met. in particular the level of homophily, which is kind of realistic. Usually we see the level of homophily in real social network, and that's why we see echo chamber effect in reality. Other than that, we also did some intervention studies where we rewired the edges to reduce these increments. We basically did a uniform rewiring, one biased by the, which is promoting the opinion diversity, and one done by degree. Of course, if you promote diversity, you get the a huge decrease in the echo chamber effect, both in the controversy, both in the correlation between the opinions. But it's interesting that also using some uniform rewiring, it can reduce a lot the level of echo chamber effect. So the take-home message is the following. People recommend the system can produce echo chamber effect if some initial conditions are met. And that's basically what we found out. And so what we did is to create this relationship between recommender system and polarization to see if one can produce an effect. We did a simulation study, and we found out that each recommender system that uses a different properties in the network can produce a different footprint in the polarization effect and echo chamber effect. So what we want to do right now is to work on detection, as Marco are gonna explain you later, and also work on the intervention. So if anyone wants to collaborate on this, just send an email and we are happy to collaborate.